Greetings, everyone. We are the Hampton University Department of Aviation Student Research Team, and we are happy to present to you all the concept of Inspector Drover. Going over the overview, we will start with a brief introduction of our team, where we will then give a background of our concept. We will then proceed by explaining the research that went behind the production of Inspector Drover. Following our research, we will explain the concept of operation and the different final designs of our project. Our team will then explain the total risk and the budget for this project and all of the future impact Inspector Drover may have on the industry. Before we begin with our project, let me introduce to you all the team here at Hampton University. My name is Julian Payne Dillard, a Senior Aviation Management Air Traffic Control Major from PG County, Maryland, and I am the Senior Co-Lead of Inspector Drover, where I was in charge of engineering and design for this project.
Hello, my name is Ryan Ford, a graduating Aviation Management Air Traffic Control Major from Upper Marlboro, Maryland. The section I'll be presenting is the problem statement and background. FOD, foreign object debris. In the field of aviation, FOD creates safety hazards and damages which affect the aerospace industry with an estimated cost of $4 billion a year. FOD can come from almost anything and can be found anywhere, but it poses a heightened level of danger when it is located on runways and taxiways.
Hi, I'm Ellis Woodyard, and I'm a third-year flight education major from Raleigh, North Carolina. And I'm going to be speaking on our research methods and the conclusions we made based off of them. Our research was done thoroughly over the past several months to make sure we got the best possible information to make a product that really worked for airport ops officials. We first conducted our own study of airport runway inspections and federal regulations attached to them, and reviewed the problems and consequences of missing runway and FOD issues. We then met with airport operations officials from Baltimore Washington International, who were able to give us a wealth of knowledge on how large airports carry out their runway inspections and check for FOD. We then began interviewing a number of other airports across the U.S. of differing size and location. Airports such as Seattle-Tacoma, Raleigh, and Denver International to get a large sample size. During this round of interviews, we asked airport managers for both objective and subjective data about their runway inspections. From there, we were able to find some reinforced trends. A large problem airports face today is almost around-the-clock work to get rid of FOD, with over 70% of airports saying it was tougher to handle than runway surface inspections. We also found that while most FOD was some sort of metal, many other materials were also found as FOD, including plastic, concrete chippings, and even biological waste. Something that was common amongst all airports was that most FOD they found was small and less than 3 cubic inches in size, about the size of a coffee mug. With those parameters set up, the group made a decision to make FOD collection our main goal and have surface inspections be our secondary, along with creating a rover that could pick up a number of materials, all of different size, with one method.
And now it is time for the Inspector Drover video. The engineering and design team has planned an effective method for the rover during FOD inspection. The rover will be housed in an adequate parking space that is easily accessible for charging or repairs next to the airport. When it is due time for a runway inspection, The operations manager will coordinate with air traffic control to start the autonomous process from their office. The rover will power on and proceed under the directions given by air traffic control to the active runway. The rover will stop before all movement areas. The rover will not continue until given clearance by air traffic control and the operations manager approve the rover to continue its operations. The rover will then proceed to the open center end of the runway and commence the inspection protocol, like we see in the video. The rover will open the drone-in-the-box solution and then deploy the drone. Once the drone is in the air and commences its sweep, the rover will follow behind the drone down the edge of the runway. When the drone signals to the rover that it detects fraud, the rover will receive an accurate GPS location of the debris and move from the edge of the runway to the fraud's current location. The rover will then drive up and scoop the debris in its front arms. Once the rover has scooped the debris, it will return to the edge of the runway and continue the fraud inspection with the drone and repeat the pickup process if needed. Once the inspection is complete, the rover will return to the center of the runway and the drone will land back onto the box solution. Once the drone has returned and is secured, the rover will promptly exit the movement area onto the taxiway. Air traffic control will then give ground clearance for the rover to return to its parking spot, and the operations manager will approve the rover for this action. The rover will then continue and stop at its designated spot and signal to the operations manager if the scoop needs to be cleared, batteries need to be recharged, or any other maintenance issues that need to be addressed before next inspection. Now time to explain more about the drone. The concept of the drone operations will be similar to the rover. The drone will be sitting inside the housing box on the rover until it is time for it to be deployed. When the rover opens the box, the drone will then raise to approximately 50 feet above ground level. Once the drone has calibrated itself in the air and the cameras are ready for use, the drone will move down the runway center line. This is the best position for the drone to examine and record all parts of the runway. The drone will use its onboard cameras and object trackers to scan for any fraud. Once the drone has detected any debris, it will calculate from its height and GPS location in conjunction with the camera angles to determine the exact location. The drone will then send this information to the rover and stay and watch the removal of the debris. Once the debris has been picked up, the drone will continue its inspection protocol and repeat the removal process as needed. Once finished, the drone will fly and return to the box system on top of the rover. Once secured inside the box, the drone will signal to the rover to close the box, and the rover will return to its designated spot.
Hello, my name is Griffin Withers. I'm a third-year flight education student at Hampton University from Lexington, Kentucky. Today, I'll be explaining our budget. We desire to have two industry partners, Icarus Incorporated that will supply the drone and ClearPath Robotics that will supply the rover. We receive invoices from both to get an estimate on how much the drone rover partnership will cost. The base price for the drone in the box system from Icarus Incorporated will cost approximately $79,000. We also suggest that airports invest in an optional accessories package. The optional accessory package comes to an estimated total of $54,000. The rover from ClearPath will cost an estimated $150,000. Combining both systems together to form the inspector drover system, it will cost approximately $282,000 in total with the appropriate modification per pair. During testing, our team has not spent any monetary resources to reach our goal of design and testing our system. Thank you.
Hello, my name is Miles Divinity. I'm a third-year flight education major from Cerritos, California, and today I have the honor to present you with the risk assessment. Due to Inspector Drover being a combination of a drone and rover pair working together, not only must we consider the risks that may come from each of these devices, but we also must take into consideration the risks that they may face when working together. My job was to analyze and assess the different risks of Inspector Drover and incorporate ways to help mitigate these problems. For starters, there are physical risks to both unmanned systems. The physical risks consist of things such as propeller failure on the drone, battery failure on each device, or flat tire on the rover. Next are the social risks. Social risks are how Inspector Drover interacts with the pilots and people in its surroundings, and how they react to Inspector Drover. The Inspector Drover system is a fully autonomous system that would be sharing the same local airspace with small rotary aircraft to large commercial jets. One of the most important risks that must be considered and that is always ever changing are the cyber risks. Inspector Drover operates on its own proprietary software system and network. Airports would invest in a network upgrade for our systems to give them the ability to communicate with our system and removes any feedback from other devices around the airport. Lastly, there are environmental risks, which vary depending on location. These risks mainly consist of different weather phenomena that may not be the same nationwide. Risks such as extreme heat, extreme cold, heavy rains, and wildlife all must be taken into account. To have a better idea of the different risks that will come from airport to airport officials must survey their airport before the initial deployment of Inspector Drover. That will help officials be ready for any sort of event on their airport. Thank you.
Hello, my name is Monte Williams Jr. I am a third-year aviation management major from Lansing, Michigan, and I'll be covering the project outline. We came together as a group in January and decided that we wanted to participate in this challenge. We thought it would be a great idea to represent the Department of Aviation here at Hampton University to get our school out there so people can know what this school students are academically capable of. We've put in our time, work, and effort into this project. Even if we don't win, we are all grateful we've come this far to have the opportunity to compete as one of the final contestants. Starting in January, we came together twice a week to brainstorm and think about ways to improve the quality of life at different airports. We developed the idea of a runway inspection drone and rover pair after several students have been delayed from their checkout rides by FOD inspection themselves. In February, we decided that we needed ways to help make runway inspections more efficient and safe to ensure that valuable flight time would not be wasted again. After we received finalist status, it was time to expand and concentrate more on our design. We then began to create a detailed development of the concept of operation design for the vehicles. We then sectioned our work and split into 3 teams: a research team, an engineering team, and a design team. Over the next few months, the research team reached out to a handful of airports, varying in different classes of airspace to interview the airport officials to get a better understanding of what challenges they have conducting runway inspections. Unfortunately, due to university regulations, we were unable to meet in person. This project was completed 100% virtually, and we were able to conduct meaningful interviews with different airports, collaborate with industry partners to perfect our design. And some students were able to go out and examine a runway in Fort Monroe, Virginia at different times to help us create the ideal concept of operations for this project.
So where will we go from here? In our opinion, the next step of this concept would be creation and implementation. The Drover system is enticing for airports because it will make a very hard job much easier. The system has quicker response times, makes more thorough checks, will do them consistently at a high level, and most importantly, keeps people safe by taking the airport operations official off of an active runway. Beyond that, the Drover has the capability to have modular attachments added to fill the needs of the future. A rover equipped with those attachments could carry out missions such as ASOS and AWOS maintenance and testing, lawn care, localizer and glide slope testing, light replacement and repairs, wildlife control, runway groove hydroblasting, hazmat cleanup, and so many other different missions. This concept has the potential to be implemented quickly and drastically increase the safety of our runways. It will immediately fill a need within our industry, and the concept as a whole can be applied to uses far outside of aviation. We want to thank you again for your time today and hope you see the impact the Inspector Drover concept can and will have. Thank you.